Dennis, can you hear me? Dennis बाबु सुन्दैछौ? आज डेनिसलाई एउटा क्वेसन सोध्नु मन लाग्यो. डेनिस विक्रम थापा. Dennis, simply say what is law of flotation? What does law of flotation state? मैले 1 मार्क्सको लागि क्वेसन सोधेँ है. State law of flotation भनेर. कसैलाई आउँछ भने voluntarily you can say the answer. And soon we'll start the class. State law of flotation. कसैलाई law of flotation को statement आउँछ भने, okay, anyone can give the answer.
A body floats on a liquid if it can displace the weight of its own body.
Very good, excellent. Yes, thank you so much. Yeah, for a floating body, the weight of body is always equal to the weight of displaced liquid. I think we can start the class now. Let's start the class with some questions. So you can see on your screen, dear students. So this is the first question that we are going to discuss today. So here you can see the table mentioning the density of 4 substances. The question is, study the given table and answer the following questions. First question is there, among the substances A, B, C, and D, so which substance floats on water? Why? So for this, for giving answer of this question number 1, let's see the table once. So in the table, you can see the density of 4 substances in both system, in SI and CGS as well. The density of A, 0. Okay, it is density in CGS system, 0.8 gram per centimeter cube, and in SI 800. Means students, when you know the density of any substance in CGS, simply multiplying that density by 1000, you will get that density in SI system. So 0.8 into 1000 is 800. So 0.8, it is in CGS, so gram per centimeter cube, and the density of same substance 800, okay, that is in SI, that is 800 kg per meter cube. So you can see the density like 0.92 of B, 13.6 of C, and 1 of D. We know the density of water in both system. In CGS, the density of water is 1 gram per centimeter cube. In SI, the density of water is 1000 kg per meter cube. Now we have to see those substances, so which have less density than the water. Then easily we can say the substances which float on water. So from the table, we can give answer as A and B, I think, right? So if you see the density of A, that is 0.8, means less than 1, and the density of B is 0.92, which is also less than 1 density of water. Yeah? So A and B, so are the substances, okay, from the given table, so which float on water, okay, that with some of its parts out of the water. So the density, okay, less than the water can float on water partially. So we can easily say A and B are the substances float on water. And the reason behind this is, so the substance having less density can displace water more than its weight. Means the substances can easily experience more of thrust. So due to which they float on water. So we got the answer of number 1, I hope. Okay, A and B are the substances that float on water. It is because they have less density water, due to which they can displace more water, and in turn they experience more of thrust that make the substances float on water. Okay, let's go to question number 2, students. In question number 2, the question is there, name the substances that give the greatest and least of thrust. So we know the formula for upthrust, that is U equal BdG. We show the relation between upthrust and density, and that shows that upthrust is directly proportional to the density of a substance. As the substance which has highest density obviously acquires the highest upthrust, that is greatest upthrust. So in table, among A, B, C, and D, C is the substance that has the greatest density. Means C the substance that exerts that gives the greatest upthrust. Okay, C the substance because its density is 13.6 gram per centimeter cube in CGS, and the same that is 13,600 kg per meter cube in SI. So among the four substances, this has the greatest density. So due to which it also gives the greatest upthrust. And among these, A is the substance which have the least density, that is just 0.8. Means now this is the substance, means A is the substance, so which gives the least upthrust. I hope we got the answer of both questions 1 and 2. Okay, and I would like to add one more question here. Okay, the question is not here, so you cannot see on the screen. A very simple question. So among the four substances, there is strange. Okay, which substance acquires the least volume? Okay, if they are of same masses. A, B, C, D भन्ने चारवटा सब्सटेन्स यहाँनिर सबैको आफ्नो डेन्सिटी छ। अहिले के मानौँ भने एबिसिडी चारवटाकै सेम मास छ, मास कन्स्ट्यान्ट छ भने यो चारवटा मध्येमा कसको चाहिँ भोल्युम मिनिमम हुन्छ, लिस्ट भोल्युम हुन्छ? ल भन त, ट्राई गर त, प्लिज ट्राई टु गेट द आन्सर। Yes, yes, that is the answer, C. Okay, among A, B, C and D, C, okay, has the minimum volume. Density को फर्मुला के हुन्छ? Density को mass upon volume. That means density is inversely proportional to the volume. भोल्युम सानो भयो भने डेन्सिटी म्याक्सिमम हुन्छ र भोल्युम ग्रेट भयो भने ठुलो भयो भने के हुन्छ? डेन्सिटी मिनिमम हुन्छ। अनि यो एबिसिडी मध्येमा सी भन्ने सब्सटेन्सको डेन्सिटी सबैभन्दा ठुलो छ, 13.6 छ। यसको मतलब सी, okay, acquires the minimum volume. Okay, now let's go to another question, please. The second questions for today. This is also a diagrammatic question. Observe the given diagram and answer the following questions. Number one question: which object displaces water equal to its weight? So you can see three objects in water, immersed in water, either partially or fully, X, Y, and Z. And by observing the diagram, you can see X and Z are floating, whereas Y is sinking. So the first question answer is, so which
Z.
object displaces? Yes, thank you so much. Z, it is Z, obviously Z. Okay, that is floating just within the water, let's say below the surface of water. Here, it displaces that water equal to its weight. Let's go to number two then. Write density of Z, means density of same substance in SI unit. The liquid is water, right? And the Z is floating within the water, means below the surface of water, where density of that body means Z must be equal to the density of water.
So
That's why
1000
we can say
kg per meter cube.
Thank you. Excellent, excellent. Okay, yes, yes. Density of Z is 1000 kg per meter cube. So for floating, okay, like this strands, just below the surface, the body must have density equal to the density of liquid. It is water. The density of water is 1000 kg per meter cube, and since it is floating in this condition, the density is 1000 kg per meter cube in SI system, right? Let's go to number 3 then. Which principle does this diagram show? Your diagram, ma?
Archimedes principle.
Thank you so much. Yes, yes. Since okay, the diagram shows both the phenomena, two objects X and Z, they are floating, and Y sinking. And in the cases of sinking and floating, so we can apply the principle given by Archimedes called Archimedes principle. Your number 3 question ma चाहिँ जस्तै which principle, okay, we can explain in jet भनेको simply we can say law of flotation. Specific floating body को लागि सोधेको छ भने त we can be particular and specific and say law of flotations. But the question is asking you to set principle of whole diagram, and since there are both conditions, floating and sinking, we have to say Archimedes principle. ल आज डिस्कस गरेको दुईटा क्वेशन क्लियर भयो होला है। ल नेक्स्ट टाइम म अरु क्वेशन लिएर आउँला। इन सर्ट ओके रिक्याप गरौँ। लास्ट क्लासमा हामीले के पढेको थियौं त्यसलाई छोटोमा एक्चुअली रिभ्यू गरौँ। In last class, students, we discussed the conditions that determine the floating and sinking of a body in the liquid. Okay, अब यो जस्तै फर्स्ट number 1 and number 3, the first diagram र अनि last 3 third diagram, it was very simple. So whenever the density of a body is more than the density of liquid, okay, it always sinks, since the weight of a body is greater than the weight of displaced liquid. The body which has more density than the liquid, that body cannot displace the liquid, okay, equal to its weight, so it sinks. एकदमै simple clear भयो first picture हैन, first condition sinking condition, density more. And third here, the densities are equal. The density of immersed body is equal to the density of liquid, due to which that the upthrust is equal to the weight of a body, and it floats like this, means below the surface. Now in second figure students, I would like to add some points today. Okay, while we observe, when we observe any object floating on a liquid or floating on water, okay, in this way, means partially floating, some of the portion of the body out of the water, means in the air, always we have to know that how much portion of the body is immersed inside the liquid or water. That portion is responsible to displace the liquid or water which is equal to the weight of body. यो यसरी पार्सली फ्लोट हुँदाखेरि पानीमा अथवा लिक्विडमा कति पर्सेन्ट डुबेको छ, अनि त्यो डुबेको भाग चाहिँ के हुन्छ त, त्यहाँनिर उसले डिस्प्लेस गर्ने जुन लिक्विडको वेट अथवा अपथ्रस्ट हैन इक्वल बडीको वेटसँग हुने रेस्पोन्सिबल हुन्छ. मिन्स okay, if we try to, let's say, immerse this kind of body which has less density than the liquid fully inside the liquid, अब के गरौँ भने यो बडीलाई पुरै भित्र पानीमा अथवा लिक्विडमा पुरै डुबाउने कोसिस गरौँ भने, so in that case we feel difficult to push this object into the water, because when it is fully immersed, this body displaces, okay, water more than its weight. That means the body experiences more upthrust than the weight. And जसले गर्दाखेरि हामीले यदि छोड्यो भने, then you can see the motion of this body. यो चलेको देखिन्छ. कसरी भन्दा it rises up. Due to the upthrust given by the liquid, now it rises up. Now it rises unless, okay, it displaces the liquid equal to its weight. मानौ यो बडीलाई हामीले धकालेर यहाँनिर पुर्यायो भने, फुल्ली इमर्स छ भने, ओके, यस्तो बडी जसको डेन्सिटी लिक्विड भन्दा कम छ भने, त्यस्तो बडीलाई फुल्ली इमर्स गराउँदाखेरि अपथ्रस्ट जहिले पनि बढी हुन्छ. यो बडीको वेट भन्दा अपथ्रस्ट बढी हुन्छ, अनि जसले गर्दा यो बडी राइज हुँदै जान्छ. अनि कति बेलासम्म राइज हुन्छ भने, अथवा कति पर्सेन्ट तिम्रो पानी बाहिर लिक्विड बाहिर आउँछ भने, अथवा कसरी रहन्छ भने, जबसम्म ओके यो लिक्विड जुन डिस्प्लेस छ नि त्यसको वेट र बडीको वेट इक्वल हुँदैन. अब फुल्ली इमर्स गराउँदा चाहिँ लिक्विड डिस्प्लेसको वेट बढी हुन्छ, अनि बिस्तारै माथि माथि जाँदा गएपछि अनि केही पर्सेन्ट बाहिर निस्केपछि अनि जब त्यसको लिक्विडको वेट र अनि बडीको वेट इक्वल हुन्छ अनि स्टेबल हुन्छ, अनि यसरी फ्लोट भइरहन्छ. So for the partially floating body, okay, that the weight of liquid displaced is equal to weight of body is determined by the immersed portion of the body. So whenever it is fully immersed inside the liquid, it always experiences more of thrust than its weight. So why it moves or it rises up, and finally it comes to some level where the weight of liquid displaced becomes equal to the weight of a body. And because of this case strange, so if we have a body which has less density on the lower part, and we are keeping or we are placing other objects which have higher density on that body, and we can see that body is found floating on the liquid. So why students, we go with the tube while we go for swimming, and we go with the, let's say, life jacket, isn't, while we do rafting like that. Even we can keep the iron object on the piece of log of wood, एउटा काठको टुक्रामा हामीले आइरन धरिराख्यो भने पनि त्यो के हुन्छ, फ्लोट हुन्छ, बिकज बिलो द्याट वुड, and wood has less density than the water. Okay, and this second case, partially floating case, has many application of law flotations. Okay, आजको टपिक, let's see application of law flotation. Before that, यो फर्मुला चाहिँ याद गर. नेक्स्ट टाइम हामी नेक्स्ट विक हामी एउटा हिसाब गर्छौँ B1 D1 equal B2 D2 when the formula is together. Okay, this is the formula that we get from law of flotation. B1 D1 is equal to B2 D2. Let's talk about the application of law of flotations. First, we have ship. Okay, we can see the very heavy ship that carrying a lot of cargo. Many people can easily float on a sea or ocean or even on the river because a ship is made wider at the base. Means, okay, I'm telling you students, whenever we change the volume of a substance, that means we can change the density of that substance. Means changing the shape of a substance means we can change the density of substance. So the base of a ship is made wider, means increasing volume. So when we increase the volume, means density decreases. And another part is lower part of the ship. Okay, consists of air chamber. The lower chamber is filled with air. So the shape means volume and the air chamber of the ship that is able to displace the water in the sea or ocean equal to its weight, due to which the ship can be made float, on sea, and it can be moved in a long distance, isn't it? As a voyage or for carrying the cargo from one place to another. Right? So average distance, density, not distance, sorry, average density of a ship is reduced, okay, by changing the shape and filling the air in the chamber, and due to which it can displace, okay, a lot of water, by which it gets more of thrust. And when a ship, okay, is moving or floating on the sea, it floats more. That means the small part of the ship is inside the water. When we bring the ship into the river and we find that hull, okay, this part is called hull, HALL hull of the ship sinks more because of the difference in density between seawater and river water. So river water is probably pure water, okay, that has less density, and seawater is salty water. So salty water has more density, due to which it gives more of thrust, and the ship floats more. But the river water density is less, okay, than the seawater, and where it cannot give more of thrust, and the ship sinks little more, okay, than in the sea. This is number one application of flotation. That is flotation of ship. Next is iceberg. The density of ice is, okay, 0.92 gram per centimeter cube, and the density of water is 1 gram per centimeter cube. Means the density of ice is less than the density of water, and the substance having less density than the liquid can always displace more liquid, due to which it gets more of thrust. So why, though ice is, okay, one of the state of water, that the water change into ice, then though it has less density, because when water turns into ice, the volume increases. There is the expansion, and the expansion causes the increase in volume. Due to the increase in volume, the ice always has less density than the water. Okay, so that it gets more of thrust. Third application of law of flotation is submarine. Okay, you know very much about submarine. So either it can be float on water, or it can be taken deep down into the water. A submarine has mainly three parts, okay, on it. The first part is engine part. And the second part is their air container or air chamber that is filled with air. And third part is, it is called ballast tank. BALLAST, ballast, TANK, tank. Submarine has three parts. So whenever, right, okay, whenever that submarine is to be or has to be dipped inside the water, or say sunk inside the water, at the time ballast tank is open so that the water can enter into the ballast tank. Means ballast tank is filled with water, and that increases the density. And once the density of submarine increases, now it goes down, okay, it sinks in the water. And when, if the submarine has to, let's say, taken up, okay, and just for floating, then the air is passed from air chamber to the ballast tank, and by the air pressure, the pressure given by the air, that the water escapes out. And once this water escapes out from the submarine or from the balance tank, again the density decreases and the submarine can displace water, okay, and floats on the surface. So this is submarine. This is applications of law of flotations. Next we have students hot air balloons. It works by the upthrust given by the air. A balloon, it is filled with very light gas, okay, either hydrogen or helium. So hydrogen and helium are the gases which have very less density. And even students, in hot air balloon, we find that the gas is made hot by giving fire or heat. Means inside the balloon, the density of air is less, and outside the balloon, okay, in atmosphere, the density of air is more. That means the atmospheric pressure now can give up thrust, okay, to the balloon. And in this case, students, when that the weight of air, or let's say weight of balloon, is less than the upthrust given by the atmospheric pressure. Now you can see the balloon rises up. It goes up to height, and it can go up to certain height. And when, okay, the weight of balloon becomes equal to the upthrust given by the atmosphere, now the at that height the balloon becomes constant, and it remains at that height. Same thing happens to our that normal balloon. So when we fill the small balloon with the hydrogen gas or helium gas, so if you release that, so it goes up, it rises up, and at some height, and it remains there. So when it gains, it experiences more of thrust than its weight. That means it moves up, and after, okay, its weight becomes equal to up thrust. Now it remains at that height. So this is the law of flotation. In this case, the air gives up thrust to the balloon. Next, we have a device. This also works on the law of flotation, students. Okay, सुन्दैछौ मलाई, मैले यही आशा गरेको छु. This device is called hydrometer. Okay, this is used to measure the density of liquid. So you can see, okay, that is a liquid field which is blue in color. So to find the density of that liquid, okay, this device, this machine, called hydrometer. This hydrometer. So it is kept inside this, and it can float erect because the lower part of this hydrometer contains lead, okay, which is heavy, and the lead, LED lead, okay, some metals are there here, and due to the weight of the lead, the hydrometer can, okay, remain erect. सीधा बस्न सक्छ लिक्विड भित्र, and it gives the correct density of the liquid. So when we find hydrometer floats more, at the time you have to know that the density of the liquid is more. hydrometer माथि आयो भने त्यसले एकदमै ग्रेटर भ्यालु देखाउँछ डेन्सिटीको, अनि हामीले के थाहा पाउँछ भने that is the liquid having more density. And there is one special hydrometer which is called lactometer. And lactometer is designed to measure the density of milk and find whether the milk is pure or not. Let me say to you, density of milk is 1030 kilogram per meter cube. Milk density 1030 kg per meter cube. And we have a lactometer, right? And if we dip to find the density of milk, now if we find the density more than 1030, for example 1050, 1060, and now we can predict or guess that some powder is mixed in that milk because the density is more. And when we find the density less than 1030, for example 1000 only or 980 like that, then we can easily guess that, okay, the seller is mixing water in the milk. So to find the purity is to check the purity by finding the density of milk. So we have a device that works on law of flotation, and the device is named lactometer. Okay, hydrometer, lactometer, they are the device, okay, the design on the basis of law of flotations. The last example, or you can say applications of that law of flotations, okay, of let's say persons, human being on Dead Sea. So Dead Sea is very salty, sea. The salty water in Dead Sea is density is about 1.17 gram per centimeter cube. So our density is when our, let's say, lungs is empty, is a 1.07 gram per centimeter cube. But when our lungs are filled with air, now the density of body decreases and it becomes equal to 1 gram per centimeter cube. याद गर है, हाम्रो लङ्समा जब हावा भरिन्छ नि भनेको कुनै पनि अब्जेक्टमा जब हामी एयर फिल गर्छौँ अथवा यस्तो सब्सटेन्स राख्छौँ जसको डेन्सिटी कम छ भने त्यो अब्जेक्टको डेन्सिटी नै घट्छ. तर when our lungs are filled with air, the density of our body decreases. तर while swimming, हामी स्विमिङ गर्दाखेरि हामीले राम्रोसँग सास फेर्न सक्यौँ, हाम्रो लङ्समा हावा भर्यो भने के हुन्छ, हामी सजिलैसँग अब हामी पानीमा फ्लोट हुन सक्छौँ. तर even if we do not know, okay, to swim, then we can float on Dead Sea. It is because the density of water in Dead Sea is 1.17, that is greater than the density of our body. Okay, then we can float there. Now let's connect to the next topic, students. Okay, now we need more two more period, let's say period for concluding this lesson. अब अर्को थर्ड पार्ट, ओके, प्रेसर भन्ने लेसनको चाहिँ एटमोस्फेरिक प्रेसर हो. एकदम छोटो छ यो टपिक चाहिँ. We start with definition, then one term, there is standard atmospheric pressure भन्ने छ, त्यो पढ्छौँ. And the device used to measure the atmospheric pressure, that is barometer. Two types of barometer we'll read, mercury barometer and aneroid barometer. And finally, we'll end the lessons by reading, okay, some devices that work on the, that is a phenomenon of principle of atmospheric pressure. They are syringe, air pump, water pump. Okay, they work by the help of atmospheric pressure. So today, let's read instead about definition of atmospheric pressures and standard atmospheric pressure. So what is atmospheric pressure? Okay, it's just like liquid pressure. So liquid exhaust pressure called liquid pressure. And same way, atmosphere, okay, it is a mixture of gases, or you can say it is a layer of air that surrounds the earth. And air means it is a matter, right? So when the substance is there, so with mass, and definitely that has weight. So due to the weight of atmosphere, due to the weight of air, that the air or any matter always, adjusts pressure, because that can give force. So when we mention the force on unit area, and that is obviously pressure. So the pressure exerted by atmosphere due to its weight is called atmospheric pressure. Very simple, students. This can be the question for 1 marks. So what is atmospheric pressure? Let's get to another. It is standard atmospheric pressure. So atmospheric pressure changes, okay, on the earth from place to place. So if you go to high altitude, so we find that less atmospheric pressure. And if you go near to sea level or low height, then we can easily, find that the more atmospheric pressures by the device called barometer. And for the earth, atmospheric pressure at sea level is taken the maximum atmospheric pressure. Get the highest atmospheric pressure. And sea level is the landform, which is the lowest level on the earth, right? So in that level, the pressure exerted by air is the maximum or highest pressure, which is called standard atmospheric pressure. So what is standard atmospheric pressure? The atmospheric pressure at sea level, right? Or you can say the pressure exerted by atmosphere at sea level is called standard atmospheric pressure. So it has fixed value. Okay, when there is normal temperature, at the time there is the fixed value of atmospheric pressures at sea level, which is standard, and it's called 1 atmosphere. We know, students, Pascal is the SI unit of pressure, right? For expressing atmospheric pressure, okay, apart from Pascal, we have other units also. So you can see ATM. Okay, ATM stands for atmosphere. So when we have any numerical value with atmosphere, so that always represents the atmospheric pressure. And then another unit is there, mmHg. mmHg means millimeter of mercury. So we'll see this in mercury barometer. Next unit also we can see the TORR. TORR is torricellion. So there is vacuum in mercury barometer, right? So that vacuum is called torricellion vacuum. That is by the name of scientists. So there is one unit to express the atmospheric pressure, that is called torr, in short, TORR. It is also torricellion, right? TORRI, okay, CELLIAN, torricellion. mmHg, this is millimeter of mercury, PM is Pascal. And another is the BAR, bar. Okay, bar means that is barometer. And next we have another is that is millibar. So atmosphere, ATM, okay, millimeter of mercury, mmHg, PA, Pascal, TORR, torricellion, BAR, barometer, okay, and then millibar. These are some units that we can use for expressing atmospheric pressure. And if you go to the sea level, the standard atmospheric pressure we find is 1 atm, so which is equal to 760 mmHg, right? And in Pascal, it is equal to 1.01 into 10 to the power 5 Pascal. So if you are asked to set the standard atmospheric pressures at sea level in Pascal, you can say 1.01 into 10 to the power 5. In mmHg, it is 760. In cmHg, it is 76 only, and in atmosphere, it is 1. Now, what is the relation between torsion and mmHg? It is 1 torsion is equal to 1 mmHg. That means 132.32 Pascal. It's for knowledge only. Okay, at the extension of knowledge. This part you have to know. Okay, 1 atm equals 760 mmHg equal 1.01 into 10 power 5 Pascal. This you must know, and this part is for extension of knowledge. So here 1 bar is equal to 10 to the power 5 Pascal. It is little smaller than the atmosphere. Right? That 1 atmosphere is 1.01 into 10 to the power 5, but 1 bar is equal to 10 to the 5 only. Means which is 750 mmHg, which is 0.987 atmosphere, and 1 millibar is equal to 100 Pascal. Understood, students? Okay, today this much. Let me come back to you. Okay, class 10. आज तिमीले मोनोटोनसली ओके मेरो मात्र एउटा लेक्चर जस्तो सुन्यौ अनि आज हामीले डिस्कस गरेको फर्स्टमा त क्वेसन हेर्यौँ रिलेटेड टु ल अफ फ्लोटेसन एन्ड डेन्सिटी, राइट? अनि हामीले त्यसपछि आज पढेको टपिक भनेको चाहिँ एप्लिकेसन अफ मिन्स युजेस अफ ल अफ फ्लोटेसन. केही एक्जाम्पल्सहरू थियो, सिप, सबमराइन, हट एयर बलुन, राइट? एन्ड देन इभन ह्युमन बडी भन्ने कुरा थियो. अनि फाइनल्ली अनि वी स्टार्टेड रिडिङ एटमोस्फेरिक प्रेसर. आज पढेको मेन चाहिँ के हो त स्ट्यान्डर्ड एटमोस्फेरिक प्रेसर फ्रम एटमोस्फेरिक प्रेसर. र आज डिस्कस गरेको टपिक मध्येमा कहीँनिर कन्फ्युजन, कहीँनिर डाउट नबुझेको जस्तो लाग्छ भने यु क्यान ह्याभ क्वेरिज प्लिज, क्वेसन सोध्न सक्छौ. अब हामीलाई 2टा पिरियड भयो भने यो प्रेसर भन्ने लेसन सकिन्छ. एकदम धेरै एकदमै लेन्दी जस्तो भइसक्यो होइन, एउटै लेसन धेरै दिनसम्म पढेको जस्तो भइसक्यो. हामी मेनली त्यो वाटर पम्प, एयर पम्प पढिसकेपछि त च्याप्टर सकिहाल्छ. केही छ अहिलेसम्म तिमीले नबुझेको अथवा कहीँनिर केही क्वेसन छ भने है सोध्न सक्छौ. यस प्लिज प्लिज. फर्स्टको 2 नम्बर क्वेसन जुन त्यो फ्लोटिङ जसमा हामीले आर्किमिडिज प्रिन्सिपल भनेको थियो नि, XYZ, त्यही क्वेसन होला नि? एबिसिडी भनेपछि फर्स्ट नम्बर क्वेसन त्यो डेन्सिटी वाला. ल डेन्सिटी वाला म फेरि एकचोटि देखाउँछु है त त्यो क्वेसन. ल वेट प्लिज, पेसेन्स. ल ल म एकछिन देखाउँछु है. त्यो फर्स्ट क्वेसन थियो नानी आजको क्लासमा. हो यही क्वेसन हो, हेर त. ल हेर है, 4 सब्स्टेन्सेस दिएको छ, एबिसिडी नाम गरेको होइन. अनि त्यसको डेन्सिटी अब 2टै सिस्टममा दिएको छ. तिमीलाई सोद्धाखेरि चाहिँ एउटा मात्र दिन्छ है, अब के सिजिएसमा के एसएममा दिन्छ. आज मैले 2टै देखाएको चाहिँ अब डेन्सिटी यसरी पनि लेख्न सकिन्छ भनेर देखाउन खोजेको तिमीलाई फर नलेज. अब क्वेसन नम्बर 1 मा हेर नानी, एमङ द सब्स्टेन्सेस ए, बी, सी एन्ड डी, 4वटै सब्स्टेन्स मध्येमा विच सब्स्टेन्स फ्लोट्स अन वाटर भनेको छ है. अन वाटर भनेको छ के, द अन वाटर भनेको सर्फेसमा फ्लोट भनेको हो नि त. त्यसले गर्दा सर्फेसमा फ्लोट त्यो बेला हुन्छ जुन बेला सब्स्टेन्सको डेन्सिटी के हुन्छ, वाटरभन्दा कम हुन्छ. अब यसको लागि हामीलाई वाटरको डेन्सिटी कति हो भन्ने कुरा चाहिँ थाहा हुनु पर्यो. है यहाँनिर किनभने क्वेसनमा वाटरको डेन्सिटी यति भनेर भनेको छैन, तर हामीलाई नोन छ. अनि वाटरको डेन्सिटी भनेको त 1 ग्राम पर सेन्टिमिटर क्युब हो. अनि यो टेबलमा हेर्दाखेरि 1 भन्दा सानो डेन्सिटी त ए र बी को देखियो. ए को 0.8 अनि बी को 0.92 है. अनि त्यसले गर्दाखेरि ए र बी चाहिँ फ्लोट हुन्छ भनेर हामीले भन्यौँ, बुझ्यो है. सो ए एन्ड बी फ्लोट अन वाटर भन्ने कुरा गर्यो. अनि यसको वाइ भन्ने क्वेसन छ. यसलाई चाहिँ हामीले के गर्यो भने दिस सब्स्टेन्सेस ए एन्ड बी हेभ लेस डेन्सिटी देन वाटर ड्यू टु विच दे क्यान डिस्प्लेस मोर वाटर एन्ड इन टर्न रिसिभ मोर अफ थ्रस्ट भन्ने हामीले वाइ भन्ने जुन रिजन छ त्यसलाई चाहिँ हामीले के भन्यो भने ए र बी को डेन्सिटी वाटरभन्दा कम छ. त्यो डेन्सिटी कम भएको कारणले गर्दाखेरि यसले धेरै वाटरलाई डिस्प्लेस गर्न सक्छ है. अनि चाहिँ धेरै अप्थ्रस्ट के गर्छ, एक्सपिरियन्स गर्छ. अनि बडीको वेटभन्दा अप्थ्रस्ट धेरै भयो भने त अनि त्यो फ्लोट हुन्छ भन्ने हामीले रिजन दियौँ, लजिक त्यसरी दियौँ. बुझिन्छ 1 नम्बर क्वेसन? आर यु देयर?
यस सर. 2 नम्बर.
अनि नम्बर 2 क्वेसन छ है नानीहरुलाई. अब नेम द सब्स्टेन्सेस दैट गिभ द ग्रेटेस्ट एन्ड लिस्ट अफ थ्रस्ट भनेको छ. अब यो 4वटा मध्येमा कसले सबैभन्दा धेरै अफ थ्रस्ट मानौ यो चारवटै लिक्विड हो अहिलेलाई, बुझ्यो है, यो चारवटै यो लिक्विड हो अनि चारवटैमा कुनै एउटा सब्स्टेन्स हामीले इमर्स गर्दैछौँ। मानौ एक्स पनि अब्जेक्ट छ, त्यो एक्स पनि अब्जेक्टलाई हामीले एमा पनि इमर्स गर्दैछौँ, बीमा पनि गर्दैछौँ, सीमा पनि गर्दैछौँ, डीमा पनि गर्दैछौँ भने अब त्यो बेलामा यो चारवटा मध्ये कुनले सबैभन्दा बढी अप्थ्रस्ट दिन्छ। अनि हामीले लास्ट टाइम हामीले अप्थ्रस्टको एउटा फर्मुला पढाएको थियौँ नि नानी, यु इक्वल भिडिजी भनेर। अनि त्योभन्दा पहिला हामीले फ्याक्टर्स एफेक्टिङ अप्थ्रस्ट भनेर पढ्दाखेरि डेन्सिटी अफ लिक्विड भनेर पढाएको थियौँ है। अनि द रिलेसन बिट्विन अप्थ्रस्ट एन्ड डेन्सिटी इज डाइरेक्टली प्रोपोर्सनल। जुन लिक्विडको डेन्सिटी बढी हुन्छ ओके त्यो लिक्विडको अप्थ्रस्ट के हुन्छ, बढी हुन्छ, मोर हुन्छ भनेर पढाएको थियो नि। अब यो चारवटै सब्स्टेन्सको डेन्सिटी हेर्दा त सबैभन्दा म्याक्सिमम हाइएस्ट डेन्सिटी त सीको छ, किन 13.6 भनेर त यसको रिलेटिभ डेन्सिटी 13.6 हो, यो त एकदमै हेभी छ है। अनि त्यसले गर्दा हामीले के भन्यो भने सी ओके इज द सब्स्टेन्स द्याट ह्याज द ग्रेटेस्ट अप्थ्रस्ट भन्यो। चारवटा मध्येमा एकदमै धेरै अप्थ्रस्ट दिने भनेको सी रहेछ, बिकज अफ इट्स ग्रेटेस्ट डेन्सिटी। अब अर्को क्वेसन छ लिस्ट अप्थ्रस्ट, त्यसै सबैभन्दा थोरै अप्थ्रस्ट कुनमा दिन्छ। अब जसरी डेन्सिटी बढ्दा अप्थ्रस्ट बढ्यो भने त ओके त्यसको चाहिँ भाइस वर्सा के हुन्छ, डेन्सिटी घट्दा अप्थ्रस्ट पनि घट्छ। अनि यसमा 0.8 सबभन्दा सानो डेन्सिटी छ। यसको मतलब के भने ए भन्ने सब्स्टेन्स चाहिँ के रहेछ, यस्तो सब्स्टेन्स छ जसको अप्थ्रस्ट के हुन्छ, लिस्ट हुन्छ, बिकज अफ इट्स लेस देन सिटी। अब तिमीलाई जान्नको लागि यो ए भन्ने जुन सब्स्टेन्स छ नि त्यसलाई लिक्विड मान्यो भने यो सब्स्टेन्स चाहिँ केरोसिन हो है। ए जसको डेन्सिटी 0.8 ग्राम पर सेन्टिमिटर हो, 800 केजी पर मिटर क्युब छ नि, यो लिक्विडले भने चाहिँ तिम्रो केरोसिन हो। तर सोलिडली भने चाहिँ वुड हो। ओके वुडको डेन्सिटी पनि के हुन्छ 600 देखि 800 केजी पर मिटर क्युबसम्म हुन्छ। तर 800 केजी पर मिटर क्युब डेन्सिटी भएको लिक्विड